Okay, so now we're going to look at a missense mutation. So again, the mutation occurs in the DNA, but we don't really care about it until we get to gene expression. So we've got, again, our DNA template strand here. Then we have our mRNA strand here that is transcribed from the template strand. And then we look at the codons in our genetic code to find out what amino acids are present here. Okay, so I'm not going to go through them all again like the last time. However, I do want to look down here. So again, this is set up the same. Okay, so this is the normal up here. And then down here is our mutation that has occurred. So again, our mutation occurred in the DNA. So here, during DNA replication, unfortunately, a T was inserted instead of a C. And it was not proofread and replaced. And so when we look at the complementary nucleotide, we actually get an A here. So this is our mutation in our DNA. Now, during transcription, we're going to look at the coding strand. And so here, the complementary mRNA nucleotide is an A. So here is our change. So we've had a change in the mRNA. Okay, so now we need to see, did that change in the mRNA cause a change in the amino acid sequence? So we could start back here at the beginning. So if we look at our genetic code, AUG gives us methionine, AAG gives us lysine, UUU gives us phenylalanine, and AGC gives us serine. So this is a different amino acid than we see up here. So here's our unmutated strand. So we look, our DNA unmutated template strand is CCG. Our complementary mRNA is GGC. And when we look that up, that codon up on the genetic code, we get glycine. So if we compare that down here to our mutated DNA, we had a TCG, which is then read to give us our complementary mRNA nucleotides, which is AGC. When we look that codon up on the genetic code, we get the amino acid serine. And the replacement of one amino acid with another tells us that this is a missense mutation. Okay. Okay, our last type of point mutation is a nonsense mutation. This type of mutation causes a stop codon to be read instead of the correct amino acid. So again, we've got the non-mutated DNA up here at the top, and we're using the same strand we have in the other one. So we've got the template strand, we've got the mRNA, we read the codons here to get the correct amino acids. Okay, so in this instance, we've got a mutation here in the DNA. So an A was added instead of a T during replication. And then when the complementary nucleotide was added, a T was added. And then down here we have our mRNA that is transcribed from our template strand. And so when we're reading an A in the template strand, we're going to get a U in the mRNA. And so what happens if we go along and read these codons? So again, we've got AUG in our mRNA, which gives us methionine. And then our next codon is UAG. Well, if you look that up in the genetic code, this is actually the signal to stop synthesizing this strand of amino acids. So all the parts fall apart. So the ribosome falls apart, the tRNAs, everything falls apart, and we're left with our strand of amino acids. Well, if this happens too early, then we get a very short strand of amino acids and generally a completely non-functioning protein. So up here you can see our normal amino acid strand was methionine, lysine, phenylalanine, and glycine. And we already talked about the fact that if this was a real protein, that string of amino acids would be much, much longer. And so down here, we've got our stop codon occurring way too early. And so we really only got one amino acid here, and then that's not going to be a functioning protein at all. So a nonsense mutation is when a mutation in the DNA causes a stop codon to be read, and then we get a stop in our string of amino acids.